I had mentioned in the previous video that for loops should not be used when the number of iterations is unknown. This code outputs hello world an unknown number of times, depending on whether or not a randomly generated number is greater than 0.2. As was previously discussed, the for loop has three parts inside the parentheses. The first part for initializing a counter and the last part for modifying the counter were omitted in this code since they are not needed. We still need to keep the semicolons to specify that the loop condition is the middle part. This code works fine, but there is a better way to do this using another kind of loop. This is the same program as the previous one, but using a while loop. The while loop also has parentheses like the for loop, but the only thing that goes inside the parentheses is the loop condition. There is no counter initialized or modified as part of the while loop's syntax. It is possible to use a while loop in combination with a counter, but using a for loop would be better for that. This outputs 0, 1, 2, 3, and 4. For comparison, let's also look at similar code using a for loop. Although the output is the same in both programs, there is one important difference in the scope of the counter. In the for loop, the counter is only accessible inside the loop. In the while loop, the counter is accessible outside the loop as well. If I add a console log of the counter after the loop, it shows the 5 for the while loop, but results in a reference error for the for loop. Getting an error may sound like a bad thing, but it isn't. Because the counter is not accessible outside of the for loop, we avoid a problem known as namespace pollution. We can reuse the name without the risk of our code being affected by other parts of the program in ways that may be unexpected if we forget that the same name was already used before. That may seem like a minor issue in small programs, but it can become a major issue in very large ones. One potential problem with using while loops is accidentally making the loop infinite. A common way in which this could happen is if the value of the loop condition is never changed by the code inside the loop body. The earlier example using a random number of iterations is a special case in that math.random changes its value every time it is called, so the value can become less than or equal to 0.2 despite the fact that nothing in the code of the loop body changes the value of the random number. This is an uncommon situation. In most cases, the values used in the loop condition are only changed from inside the loop body, and forgetting to do this results in an infinite loop. Consider what happens if we forget to increment the counter. The value of the counter will remain 0 after every iteration, so it will always be less than 5. That means the program will not stop running until it is forcibly closed or crashes. If the program had any other code that was supposed to run after the loop, that code would never run. This is typically how programs freeze. Interactive parts of the code can't be reached because the infinite loop prevents it. The break keyword works with while loops the same way as it does with for loops. This code outputs 0, 1, and 2. The break executes when the counter is 2. That exits the loop immediately. That means we could change the loop condition to always be true and the loop would still not run infinitely. The continue keyword also works with while loops the same way as it does with for loops. This code outputs 1, 3, 4, and 5. The continue executes when counter is 2. That skips the console log and moves on to the next iteration. You may have noticed that I rearranged the code for this example. This was necessary to prevent an infinite loop. If the increment of counter was after the continue, the value of counter would stop advancing after it reached 2. That would make it always less than 5, so the loop would be infinite. Because the while loop condition is checked at the start of the loop, it is possible that the body of the loop will never run. This code will never output anything because the condition is not true at the start of the loop. For situations in which we want the body of the loop to run at least once, we can use a do-while loop. This code will output hello world once despite the fact that the loop condition is never true. The structure of the do-while loop is the same as the while loop, except that the condition is placed at the end of the loop and the do keyword is placed at the beginning. This is the earlier example that logged hello world an unknown number of times. This time, the loop condition is checked after the body of the loop has run, which guarantees that the body of the loop will run at least once. I had previously mentioned that there are several different kinds of for loops. One that we haven't covered yet is the for in loop. This is used to iterate over the keys of an object. This code outputs name, age, and city. If you wanted to output the corresponding values, you could make use of the key with object bracket syntax. It is possible to use the for-in loop on arrays, but there are better alternatives. This code outputs 0, 1, 2, and 3, which are the keys of the array. We can also use bracket notation to output the values. If your goal is only to iterate the values of an array, there exists a for-of loop. This code outputs 10, 20, 30, and 40. We could use a for each to produce the exact same output. Note that there is a difference in the syntax if you want to stop execution of the loop before it ends. The for-of loop can be stopped using the break keyword. When using for each, the return keyword is used instead. The for-of loop can also be used with objects, but it requires the extra step of converting the object's values into an array using object.values. It may seem unnecessary to have for-of loops when for each exists, but for each only works on arrays and array-like objects. The for-of can be used on other kinds of data structures classified as iterables. One example of this is using for-of to iterate the characters in a string. This code outputs the letters in hello, one letter on each line. Note that trying to use for each directly on the string would fail with an error because strings are not JavaScript arrays. It is possible to convert strings into arrays, but that is unnecessary and less efficient than using the for-of loop. There are other kinds of iterables that can be used with for-of loops, but we will cover those in future videos. In the next video, we will revisit the topic of strings and cover various types of string manipulations beyond just concatenation.